Hi folks, welcome to our review session for college algebra. You'll see over on the right hand side there's going to be a chat box, so if you have any questions along the way, I strongly encourage you to actually use that chat box and write your questions, and I'll try and answer them as we come along. And so you can see hopefully that we have a series of problems kind of lined up, and hopefully this will get you help in preparation for that exam. So without further ado, we're going to get started and we're going to simplify the following expressions. So we'll have a few of these of this type. We have the square root of this quantity underneath the square root 16x to the 6th times y to the 8th. So how can we actually break this up and simplify it a little bit? Well, the first thing that might become useful, notice how we have the 16, the x, and the y. Those are all separate terms. So let's break those up into different square roots. So we'll do the square root of 16. We'll do the square root of x to the 6th, and we'll do the square root of y to the 8th. Now, just a little warning here. We can only do this because we have multiplication. If this was addition, all bets are off. We can't do this anymore. So since it's multiplication, though, we can break it up into the different square roots. Now, moving forward from here, what actually happens? Well, we get square root of 16. Well, what times itself would give us 16? Well, that would be 4, so we have 4 for that solution. And now for the x to the 6th, we're going to do a little bit of work. If we take a look, what does the square root actually mean? Well, it means raised to the 1/2 power. And so that's what I'll actually write here if you're struggling deciphering that. So we can write that as x to the 6th raised to the 1/2 power, and then we can do the same thing for y to the 8th. Okay, now going forward from here, where do we go? Well, we can actually multiply those exponents. Now I'm going to give you a little bit of caution here in a second, and we'll come back and kind of figure that out. But so when you go and raise an exponent raised to some exponent here, so like we have x to the 6th and that whole quantity raised to the half, you can just multiply the 6 and the 1/2, and that should be your answer. Same thing, we get y to the, and then we'll have 8 times 1/2. So notice now, this would give us, if we multiply that out, that would be 4x cubed y to the 4th. Now I want to bring to your attention though, I'll put if x is greater than 0. And it's usually assumed that it is for the most part. Notice though, when we take x to the 6th power, we're going to get a positive number. And so the way to fix this, if we have, say we had a negative value for x in here, and I'm talking this x value in that position, if you did happen to have a negative value, notice you could raise it to the 6th power, it turns positive, but then it would be negative when we have the cube there. Notice the same thing does not happen because we have y to the 4th, that'll remain positive. We have no concerns about the y's. It's the x that gives us the concern. So the way to fix that, if you have to, is just take 4, and then instead of x cubed, we'll take the absolute value of x and cube that. And that solves it completely for all values. Right? It's only a tricky part that happens every now and then with the square roots. You really won't see it much in this class. It's mostly assumed that you're having x greater than 0. But just so you're aware, if we did have a negative value, we could turn it to positive, so it is satisfied. It's in the domain of this square root here. That accounts for that. So. Okay, so I don't see any questions. If you do have any questions, once again, there's a chat box over on that right hand side. Please feel free to ask them. But I don't see any questions at this point, so we'll keep on moving along. So in our next problem, notice we have this square root of 8r to the 12th, and then we have a q to the 7th, and underneath we have a 2r to the negative 3, and then a q squared. So let's actually break this apart a little bit. So we can rewrite this as a square root of 8, the square root of r to the 12th, and the square root of q to the 7th, all over. We have 2, and then this would be r to the negative 3, and then we'd have a q squared. Okay, now what I'd recommend, since there is no addition symbols, this is all multiplication, we can break this apart in terms of the constants, the r values, and the q values. And so that's what we'll do. So we'll have square root of 8. Well, I'll actually rewrite that though. We want to try and simplify this as much as we can. And so what's the perfect square coming out of the 8? Well, you'd have 4, so we'll write this as square root of 4 times 2, and we'll deal with that in a second here, which is all over 2. Then we have times, let's work on that square root of r to the 12th. Remember, we just talked about that's raised to the 1/2 power, so this is r to the 12th raised to the 1/2 power, all over r to the negative 3. And then that's multiplied by, well, this is q to the 7th raised to the 1/2 power, all over q squared. And so now where can we go from here? Well, we could break apart the first one into square root of 4 times square root of 2 all over 2. The next one, r to the 12th raised to the 1/2, that would be r to the, well, we go 12 times 1/2. And if you get good at this, you won't have to show all these extra steps, but I'm just making sure we're aware as to why these are happening for right now. And then last but certainly not least, we'll have that q to the 7 times 1/2 all over q squared. Okay, so where do we go from here? Well, square root of 4 is 2, so you have 2 over 2 times square root of 2 all over 2. We'll simplify that in just a second. Our second one, 12 times 1/2 is just 6, so this is r to the 6th, and then we have an r to the negative 3. And next, we'd have q to the 7 times 1/2, that's q to the, let's write it as 7/2, or you can write it as 3.5 would be the other option, whichever you kind of prefer. So I'll write 7/2 though, just for kicks. So to the 7/2 over q squared. Now what happens? Well, the 2's will cancel in that first part, and notice we're left with just square root of 2. Now if you have r to the 6 divided by r to the negative 3, what do? Well, we subtract the exponents. That's one of our properties there of exponents. So you get r to the 6 minus, and then I'll put in parentheses, negative 3. And then our next one, the q, we got to subtract the exponents there because we're doing division. So you get q to the 7/2 minus 2. Okay, so the square root of 2 will remain the same. But notice 6 minus negative 3, that becomes 6 plus 3, which is 9. So this is r to the 9th. And then q to the 7/2 minus 2, that's going to be essentially 3.5 minus 2, which is 1.5, or 3/2. And that's our final answer. So it's a simplified format of what we started with. So hopefully that makes sense on those, and you see how to simplify these involving roots and fractions and all sorts of stuff. Expanding upon this, notice none of these had addition or subtraction involved, and so that's what we're going to start to get into, is how do we actually do this when we have the addition or subtraction involved. Well, in this case, what we need to look at is we have a fraction, and you need to get the least common denominator is usually your best bet. You don't have to necessarily get the least common denominator, it'll just save you time if you do. So what is going to be the least common denominator? Well, we'll need to work a little bit in order to write it. So we get minus 3x minus 11. And then notice x squared minus 16 is the difference of squares. What do I mean by that? Well, there's a formula that we have. Difference of squares says x squared minus y squared equals x minus y times the quantity x plus y. Okay? And so in our case, our y value is 4 squared, essentially. So you have x minus 4 and x plus 4. And that's useful because it tells us what our common denominator is. In our case, if you take a look, and let me actually go and switch to a different color here, we have the x plus 4's in common. So the only thing missing in that first term is the x minus 4. So you get 2x plus 1 over x plus 4 times, and now we'll have to multiply by x minus 4 over x minus 4. Now the reason we do it on top and bottom is because we've multiplied by 1, we haven't changed the fraction. If I just multiply the top by it, or by the multiply the bottom by it, x minus 4, I've got a totally different different function here, or different expression I should say. So you don't want to make those change too much. So we go x minus 4, x plus 4. And now you can use your FOIL method. Okay, and so it goes first times first, so you'd get a 2x squared in that first term. Outside times outside, so 2x times negative 4 is minus 8x. Inside times inside, so that's plus 1x. So I'll just write plus x. Then last times last would be minus 4. And all that's over x plus 4, x minus 4. And notice we have the common denominator, so what we can actually do is we can extend this just to one fraction. And here's the last trick that we need to do. Minus, and we need to put in parentheses 3x minus 11. The reason we put that in parentheses is because that subtraction is to that whole fraction, not just the 3x. And that's the most common mistake that I see, is most people will just put it on the 3x. So when you move forward from here, notice we have the 2x squared. That'll continue, so 2x squared. You have minus 8x plus x. That's going to be negative 7x. And then we have to subtract off an extra 3x. Okay, yeah, and I'll kind of highlight here what I'm talking about. So we have negative 8x plus x is negative 7x. And then this becomes minus 3x right there. So notice that would make minus 10x. Okay. And then last but not least, we have a minus 4 minus a minus 11, so that would be plus 11. Minus 4 plus 11 is plus 7, I believe. Okay. And then our denominator is just x plus 4, x minus 4. Now you can check and see if this will factor. It doesn't take too long. You could even use the quadratic formula on the top to see if it factors. It would be a perfect number if that's the case, like a fraction of some sort. In this case, it's not going to be, because if you look at your factors of 7, it has to be negative 7, negative 1, because you have a negative 10 in the middle. And then there's no way you can multiply 2 times one of those to get negative 10 as the sum. So the numerator can't be factored, the denominator can. So that's our final answer for that one. Okay. So moving into the next problem, let's take a look at that. What actually happens here. In this case, we have to try and factor all these terms. So there's going to be a whole bunch of hoopla going on here. X squared plus 8x plus 15. I believe that goes x plus, well, we're looking for the factors of 15 that add up to 8. And it's got to be plus and plus. So that means we'll have x plus and another x plus. And so this would be 5. And then the second one would be 3. Okay, and then for the x cubed minus 8, so recall from our difference of cubes, if you go x cubed minus y cubed, that's just x minus y times x squared plus xy plus y squared. And you can factor that out or expand that out just to double check to make sure. But so that means, notice our y is 2, and so we can plug that in. Notice we get x minus 2. And then we get x squared plus x times 2 plus 2 squared. Right? And in a similar manner, we talked about difference of squares here coming up, so we'll see it again. But first we'll factor that top one. So times x squared plus 5x minus 14. So that's going to be a plus and a minus in this case, because we have a minus sitting there. So we'll go x plus and x minus. So notice we have two things that multiply to negative 14 add to 5. So that means our plus has to be 7 and our minus has to be 2. Notice they multiply to negative 14 and they add to negative 2. So, and then our denominator, that's just a difference of squares. 25 is 5 squared, so that's going to be nice and easy for us. That's x plus 5, x minus 5. Okay? Any questions thus far? Okay, I see a couple of you watching, so if need be, there's a chat box over on the right hand side, so please ask questions if you have them. That's what I'm here for. That's my main purpose, is just answering questions. So now we're ready to kind of rock and roll and see where we can go from here. Notice the nice part here with multiplication, we can actually start to cross some things out. So we have the x plus 5s, they're gone. Okay, the x minus 2s are gone, because you have one appear in the denominator, one appear in the numerator, so those things cancel. So what are we left with? Well, we're left with a good old x plus 3 times x plus 7. And in the denominator, we're left with x squared plus 2x plus 4, which cannot be factored in x minus 5. And that's good. You have everything factored, everything's nice and looks nice and easy for us, and so we're good to go there. That's all we need to do. So there's how we simplify some expressions when they have addition and subtraction involved, and then the other case prior to when they didn't. So now what we want to try and use that stuff for is so we can actually factor, and then we're going to try and solve some equations here soon enough. Okay. So we have 4x cubed plus 108. The first thing that comes to mind, notice the 4 is in front, so you have 4x cubed plus 108. I think that can factor out a 4, and then you have x cubed plus a 27. So just like we had a difference of cubes, you have a sum of cubes formula that goes x cubed plus y cubed, and that should equal x plus y. And then it goes x squared minus xy plus y squared. Okay, so keeping that in mind, what do we have? Well, we have, this is now 3 cubed, essentially, sitting in that last piece. So all we need to do is wherever we see a y, so right here, and here, and here, we're going to plug in 3. So we get 4 times x plus 3, and then x squared minus x times 3, and then plus 3 squared. So what does this equal at the end of the day? You get 4 times the quantity x plus 3 times x squared minus 3x plus 9. And you're done. That's it. So just using those formulas, that's kind of the main idea, and then also being able to factor quadratics and factor by grouping. That's another one that pops up over and over again. In our next one, a little bit more interesting. So notice we have an x to the 8th minus 256. Well, just to write it so we can see it in a different format, x to the 8th is just x to the 4th squared minus, and 256 is 16 squared. Right? So I see a question popped up. I was wondering if you can go over factoring expressions with fractions, adding and subtracting rational expressions, and simplifying complex expressions, please. Yeah, actually, so I just covered some of that. So in the first part, what I had is I had done the simplifying rational expressions without addition, so where you have the roots and all that stuff involved. And then the factoring expressions and stuff, you can see on the previous page right here, that's what we're kind of going through, is so number 2 especially, we're dealing with, hey, we got to factor these things, and then we can simplify this. And then the complex stuff will be coming towards the end of this review. So I'll have all that included in there. Hopefully that makes sense for you, Ria. Does that seem good? And did you miss the first part or not? Or yeah, just let me know either way is what we're kind of building towards, and we'll try and solve some equations as well. So, and there will be some lag time for when I see, just an FYI for future reference. There will always be a little bit of lag time, about 1 minute to 2 minutes delay from when I'm speaking to when I'll actually get your questions. So, and same thing with responses. So just let me know, and I always have my eye on that, so whenever those questions pop up. But just be patient, and I promise it'll get answered sooner or later. So now, moving forward on this one, you have an x to the 4th squared minus 16 squared. How do we actually handle this? Well, that's a difference of squares. So our difference of squares goes x to the 4th minus, and then we'll have an x to the fourth plus, and then 16 is what we have over here. So you have 16 and 16. And it seems like we're done, but we're actually not in this case. So how do we actually work this out from here? Well, x to the fourth 16 minus 16, this is x squared squared, and then this is minus 4 squared. So the way we can break off that first term, that x to the fourth minus 16, you have x squared minus, and then an x squared plus. And then we'll have the x to the fourth plus 16 because there's no sum of quartics formula. Technically we need that. So, oh, okay. See, you missed the first part of the video. Yeah, and I'll upload this with every review session. I'll actually go through all these and then I'll upload it to the announcements page. So you'll be able to see this on the announcements and you'll be able to review it as many times as need be, so for future reference. Okay. Yeah, moving forward from here, notice our 4 is our magical number, so we go x squared minus 4, x squared plus 4. There is no sum of cubes, sum of squares formula. We need, in both of these cases, we would need the complex numbers if we were to factor those things. So this one though, notice this is x squared minus 2 squared, so that's also a difference of squares. So essentially we can write this as x, and 2 is our magical number, so we go minus 2 and plus 2. And so our full-on factored formula is x minus 2, x plus 2, x squared plus 4, x to the fourth plus 16. Okay, so that's our final answer. We can't factor it anymore, and that's what we're kind of looking for. If you can factor when you're asked to solve for equations, because that's really what we're building to with these, is if you can factor those, then you actually can set each factor equal to 0 if you're trying to solve and find a solution, and then you're good to go. Okay. So now this will tie in kind of to the questions being asked just a second ago. So this first problem, you have 3 times this, or 3 over x minus 7 minus 5 over x plus 2 equals 0. So we're going to need to kind of work this out. There's a few different ways to go about it. And so one method is to get a common denominator right away. Another one we can go through is cross multiplication. The first way I'll go through is just the common denominator. And so in order to do that, the common denominator will need a factor of x minus 7 and a factor of x plus 2 in both places. So when you start with the 3x minus 7, notice what's missing is x plus 2. So this will be a little bit longer, but it'll illustrate that simplifying of fractions and all that stuff. Minus, in the other case, you have 5 over x plus 2, so what factor is this missing? It's missing x minus 7 to have that common denominator. And so that's what we'll do there, and all this equals 0. Okay, so when we go through this, we have 3 times the quantity x plus 2 minus 5 times the quantity x minus 7. And all of this is over since we have our common denominator, x minus 7, x plus 2. Okay? So, taking a look at this, what do we have? We'll have, you distribute that 3 to both terms. So you distribute it here and you distribute it there. So you get 3x plus 6 minus 5x. And let me say this minus 5 goes to the x, and this minus 5 goes to the negative 7, plus 35. And all that is over x minus 7. Oh. X plus 2. Sorry, I forgot to put in that first piece, I wanted it equal to 0. And that's the same thing as this thing being equal to 0. So now all we need to do, we have our denominator, we just can't have the denominator equal 0. So what this means is we can't have x cannot equal negative 2 or positive 7. And how do I get that? Well, we go x minus 7 equals 0, and that means x equals 7. So that would be a problem point because we'd have a 0 in the denominator. Same thing with x plus 2 equals 0. That gives us a 0 in the denominator. So both of those points have to be rolled out. So this can't happen. But if we're fine the rest of the way, the only thing we're trying to satisfy is 3x plus 6 minus 5x plus 35 equals 0. Okay, so how do we go about doing this? Well, we get everything with an x term on one side, everything without an x term on the other. So we have the 6 and the 35, so you have 6 plus 35 we'll leave over on this side. And then we'll subtract the 3x, so that's negative 3x, and then we add the 5x, so we go plus 5x. So 6 plus 35 is 41. And negative 3x plus 5x is 2x. And so now our final answer for all of this, we can divide both sides by that 2, and notice we get x equals 41 over 2. Now that was a lot of work, and the nice part here though is that we had a linear equation, and what made this equation difficult was the fraction most likely. And so I'll show you a quicker way to get to this. And notice the reason why we can say 41 over 2 is our answer, because it doesn't equal negative 2 or positive 7. So we're good. Now, so we have that. I'm going to show you a different method, something that'll work a little bit more in our favor in terms of how we can work when we have an equal sign involved versus an expression. So that shows you how, if we were just to go about the expression itself, trying to simplify that, when we have that equal sign, it can cut off some of the extra work for us. And the way we can kind of handle that, there's a nice little trick here, is to add this over to the other side, this 5 over x plus 2, we can add it over to the other side of the equation. So if we do that, we get 3 over x minus 7 equals 5 over x plus 2. Now what we can do from here is really quite clever. The common denominator that we found before was x minus 7 times x plus 2. And that's exactly what we'll use. We'll multiply both sides. You can't just do it to one side, you have to do it to both sides. But if you multiply both sides of the equation by x minus 7 over x plus 2, you'll have something wonderful happen here. So you have 5 over x plus 2, and then you have an x minus 7 and an x plus 2. And hopefully all that fit on the screen. Good. Seems like it did. Okay. So now what happens? Well, the x minus 7's on the left-hand side cancel. And the x plus 2's on the right-hand side cancel. And so notice, rather than having to get some simplified fraction, all of a sudden what do we have? We have 3 times the quantity x plus 2 equals 5 times the quantity x minus 7. Okay, so this becomes, notice when you distribute the 3, you get 3x plus 6. Oh yeah, that looks familiar, right? And then you get 5x minus 35. And so hopefully that's a little bit easier for us to handle. And now, moving forward from here, remember, get all your x terms on one side and get all your constants on the other, in this case. And the reason why we're saying that, x is to the first power. If it's to the second, we do a little bit different of a ball game. And I'll explain that in just a second. So notice we'll get 6 plus 35 on the left-hand side. And then we got to subtract the 3x over to the other side. So 5x minus 3x. Okay. 6 plus 35 is 41. 5x minus 3x is 2x. And so notice when we divide both sides by 2, once again we get 41 over 2 equals x. Same exact answer, just a different approach. I don't care which one you use, and that'll be the same for all these. I don't care what you use as long as you're able to show your work and kind of get at the answer some form or another. So obviously the second format was a lot more efficient. So you can keep that in mind. Now in the second problem, what a lot of people will try and do when they see something like this is, okay, same thing, get all your constants to one side, all your x's on the other for when we have a quadratic. The reason why this is a quadratic, you have an x squared, this exponent right up in there. That tells us this is a quadratic. But quadratics behave differently. The way to solve quadratics is we get all the terms, including constants, on one side. So what that means is we're going to have to rewrite this as x squared plus 9x and then minus 3 equals 0. Okay? Now, moving forward from here, first step you can try and do is factor. If it can be factored, things are going to be easy. Unfortunately, when you take two things that multiply to negative 3 and add to 9, that's impossible because your only factors of 3 are 3 and 1. So, and there's no way you can take 3 and 1 and sum to 9 with negatives or positives without having anything in front of that x. So this can't be factors. So what we have to use is this fancy quadratic formula. And you'll get to hear my beautiful music voice here in a second. So if you're to solve this, the formula goes x equals, and we usually sing it to Pop Goes the Weasel. So it goes negative b plus or minus square root b squared minus 4ac all over 2a. So when you sing that, hopefully it hits home and you'll start to remember it if you do it enough times. Either that or get some funny looks when you're at a coffee shop. So taking a look at this, A, B, and C, we know what A is, right? You might not see it right away, but in our case we have A equals 1. What does B equal? Well, B is positive 9. And then what is C? This is the tricky part. Notice it has a plus C. Since we have a minus, you can write that as plus negative 3. So this C is negative 3. So that means when we're solving this thing, you get x equals negative b, so that's negative 9, plus or minus the square root of b squared, so that's 9 squared, minus 4 times a times c. A is 1, c is negative 3. We already talked about that. Okay, and then all over 2 times a, so that's just 2 times 1. Okay, so if we're to actually write this out, x equals negative 9 plus or minus the square root of, that's 81 plus 12, which should be 93, I believe. So all over 2. And so what this means is there's 2 solutions. Okay, and that happens quite frequently in quadratics. You get negative 9 plus square root of 93 over 2. And then the other solution is negative 9 minus square root of 93 over 2. And that's all, folks, on that one. Okay, so you've seen how to solve quadratics and linear equations, and those are 2 big ones that you want to make sure you can do in all formats. Okay. And then inequalities is something else that we have to deal with, and the same rules apply that we saw in that first step. The only difference with inequalities, it's easier to get rid of fractions by finding the common denominator, right? If you can get a common denominator, things are good, life is easy, right? In this case, when we take a look at what's going on here, the common denominator, notice we have 3 here and a 5 here. They have no factors in common, so the least common denominator would be 15. So the way we can do this, and here's where you have to be careful. If it was a negative number, we have to switch the direction of the inequality. And we'll talk about that in just a second. Don't worry, I have an example where we get to see that firsthand. So you get 15 times 1/5, and then you get 2x minus 3 is greater than 15 times 2/3 times 5x minus 1. And that 15 came from finding that common denominator. Why do we do this? It makes our life easy, because the 5 will cancel off with a 15, and you're left with a 3 here. And then the 3 will cancel off the 15, you're left with 5 times 2. So notice this becomes 3 times 2x minus 3 is greater than 10, because 5 times 2 is 10, times 5x minus 1. Okay, so distributing that 3, you get 6x minus 9. It's greater than 50x, woo, minus 50. Oh, no, minus 50, I'm sorry, minus 10. Sorry, brain fart there. Okay, so now moving forward from here, usually what we want to do is we want to have positive x, because as I said, if we get a negative some number times x, we'll have to divide by that later and get a flipping of the inequality. So I try and avoid that personally, but not saying you have to. If you feel comfortable, just remember to flip that sign. So notice we'll get the plus 10 on this side, so we treat it just like we were solving an equation, and then we get 50x minus 6 on this side. 6x, I should say. So notice that makes positive 1 here is greater than, this would be 44x. And so notice that means x would have to be less than, when we divide by 44, we do not have to change the direction of the inequality because it's a positive number. So x is less than 1 over 44. So what does that look like? Just so we have some perspective. Okay, so somewhere along here you have 1 over 44, right? It says strictly less than, so we'd have an open circle, and then if we were to shade this in, we'd shade into this direction. Because, for example, -5 is less than 1 over 44, so you're in good shape there. So the way we write this interval, notice we can go all the way to negative infinity. So if we had to write it as an interval, you'd have negative infinity, and then it goes all the way to 1 over 44. And then we have parentheses because we don't want to include that point. Any questions on that? Please ask them if you got them. That's what I'm here for once again. So if you got questions on that piece, I'm happy to answer them. Okay, so I don't see anything popping up just yet. If not, just let me know. I'll be happy to go back to that component here while I'm working on this one too. So on our next one, we have 1/4 less than or equal to 9 minus 6x, which is less than 4/5. Okay, so this one's a little bit trickier in terms of we still have fractions, right? And we're going to be dealing with this middle sort of inequality. So in this case, we have 1/4 less than or equal to this 9 minus 6x less than 4/5. If we wanted to get rid of those fractions, because we don't want to subtract with fractions and things like that, not saying you don't have to, you can work it if you want, but I'd recommend just making life easy on yourself. So our fraction is actually 20, so we go 20 times 1/4 is less than or equal to 20 times this whole thing. That's the tricky part on this. You got to make it the whole piece. So you get 9 minus 6x, and then less than 20 times 4/5. Okay. So now moving forward from here, where do we go? We get 20 divided by 4, that's going to be 5, is less than or equal to, so now distributing this, 20 times 9 would be 180 minus 6x, that would be times 20, that would be 120x. And then this one's kind of fun too, so you get 20 and 5, those cancel, you're left with 4 up here, 4 times 4 is 16. So we're in pretty good shape there. Okay, so now what we have to do is subtract 180 from everything, and I'll actually write out that step. So you get negative 120x in the middle, and then less than 16 minus 180. Okay, so the first one will have negative 175, I believe. It's less than or equal to negative 120x. And that's less than, so what is that going to be? 164, I believe, with a negative symbol right there. Okie dokie. So now the fun begins one more time. So now we have to divide everything by negative 120. But remember, we mentioned before, when we divide by a negative, we switch the signs on the inequality. So this becomes negative 175 divided by negative 120. But we got to switch that sign of the inequality, so this becomes greater than or equal to. This would become just x, and then this would be greater than, because we're going to divide by the negative again on this side. We got to do it to all parts, so and negative 164 divided by negative 120. Okay, so let's see here. What can we do with all these? I think in our first one we definitely have a common factor of 5, so we can divide by 5. What does that become? Let me see, 35 maybe? Yeah, so if we divide by 5, we have, it'd be, yeah, I think that would work. 35, so when we divide 175 by 5, we'd get 35, and then 120 divided by 5, I believe, is 24, and I think those have no factors in common now. So that's greater than or equal to x. So now what about the 164? I think we can divide that by 4, and that will be the best common factor that we'll do. So I think we'll get 41 over 30 in that case. So just to make sure that the numbers make sense, the 35 over 24, that should be around like 1.45 maybe, something like that, and then the 41 over 30 will be something like 1.36, I believe. So either way you look at it, here's what you're getting. So you get the 41 over 30 is the smaller of the two, so it appears right there, And then the larger of the two, they aren't very far apart. So this isn't necessarily to scale. But the 35 over 24 we're including, and the 41 over 30 we're excluding, and we're taking this stuff in the middle. So how do we write that as an interval? Well, the smaller number, we're going to have a parenthesis because we don't want to include it, so you put 41 over 30. And then you go all the way up to the 35 over 24 because that's the larger of the two. And then we want to include that, so we put a bracket. And that's what we have. That's our final answer, and we're good to go. So last but certainly not least, the question appeared before, and I made a promise that we do complex, rational, kind of writing these things in standard form, so that's what I want to kind of go through. The big thing with complex numbers that I want to kind of mention off on the side here. First off, I, what is it? Well, I is actually a solution to x squared plus 1 equals 0, and so we call it the imaginary number. I equals square root of -1. So what that means is if you square I, so if you square that square root, you get -1. If you cube I, you actually get -I. And then if you take I to the 4th power, you get back to 1. And that's the beautiful thing, and then this thing just cycles on through. So if you have like I to the 5th, that's I to the 6th is just -1, and so on and so forth. So expanding this first one, we're going to have a little bit of work to do, and write it in standard form. For those of you that don't recall what standard form is, that's a plus b times I, where a and b are real numbers. That's essentially what we're looking for here. Okay. And as I said before, any questions, please ask along the way. I like seeing some earlier. That was perfect. So now, first times first, so it goes 4 times 5, which is 20. Outside times outside, so you go 4 times 7i, which is 28i, so plus 28i. Inside times inside, minus 3i times 5, so that's going to be minus 15i. And then the fun one here, minus 3i times 7, positive 7i, that'll be minus 21. I times I makes I squared. Okay, so the I squared doesn't look to be in standard form. So we got a little bit of work to do. So you can write this as 20. 28i minus 15i would be plus 13i. So we're in pretty good shape there. Then the next piece that we have to work with is this minus 21i squared. So minus 21, and I squared, if you look over here, I squared equals -1. And so that's what we'll write that as. So minus 21 times a -1, notice that's plus 21. So this whole thing is just plus 21. So this thing becomes 20 plus 21, which is 41 plus 13i, and that's your final answer. So the reason we started with this one, because you're going to need that same idea to work the second one. If you have 3 minus 5i over this quantity 1 plus 2i, we have to worry about this thing called conjugation in order to handle this. So you don't want an I down in the denominator, and the way to fix that is you can recall if we do a plus b times a minus b, notice that equals a squared minus b squared. Now why would that be so useful? Well, notice it'll end up squaring the I, and when you square I you get -1. So that's essentially what we want to do. Is we have the a plus b, granted it's not bi, but what we're going to do is just take what's called a conjugate, but we can't just do this on the bottom. So if I go 1 minus 2i, it will fix our problem down below because we'll have a difference of squares. The I squared will turn into a real number. But what we have to do is we have to also do that up top. Okay, that is the tricky part on all these. Anytime you have a rational expression. Does that make sense? I know the question was being asked before. I want to make sure we're hitting this home in terms of the conjugation thing. Because no matter what you're doing, you're always going to look for just what the conjugate is. So if this is a plus, this will be a minus of the same thing. If this was a minus right here, then this would be a plus over on this side. That's all that you're doing every time, and then we're going to just have to simplify. Just remember to do that in the numerator as well. But that's the real trick. It's called conjugation. So moving forward from here, I don't see any questions. If there are, as I said, I'm checking it out, so please ask. What does that mean? Well, this is a difference of squares, so remember this is 1 squared minus 2i the quantity squared. All right? And then up top we'll have 3 minus 5i times 1 minus 2i. Okay, so the 3 has to be, we go first times first, you get 3 right there. Outside times outside, so you get 3 times negative 2i is 3 minus 6i. Inside times inside, negative 5i times 1 is negative 5i. And then negative 5i times negative 2i, that makes positive 10i squared. Okay, the next piece, you have 1 squared minus 2 squared. I don't know why I wrote 1 squared again, but whatever. So 1 squared is 1, so we aren't going to be too bad there. Minus 2 squared times I squared. So this whole thing, notice we can combine the negative 6i and negative 5i. So you get 3 minus 11i plus 10i squared. So that's going to be plus 10 times, we know I squared is negative 1. That's going to be useful to us in just a minute. Down below, what do we get? We get a 1 minus 4 times, and then I squared is negative 1. Okay, so this becomes 3 minus 11i, but this is negative 10 now. So 3 minus 10 is negative 7. Okay, minus 11i. All over. 1, and then minus a minus, make plus, so 1 plus 4 is 5. And to write this in standard form, since there is no plus sign down below, we can do this. We can break it up into 2 separate fractions. You got to be careful if you're doing this otherwise. But so we go negative 7/5 minus 11/5. Now I could leave the I up top there, but technically we usually want it in that form if it says B, A, and B are real numbers. So this would be our final answer. That is how you simplify a rational expression. Any questions on this? So I don't see any questions, and with that in mind, this is pretty much getting you ready for that first exam. So I want to make sure you're prepared. Please take a look, and if you have any other questions, post them in the discussion boards or post them in the YouTube live questions ahead of time. I'll be happy to answer those along the way as well. So just, yeah, ask questions. That's the big thing, and kind of we can reiterate. And if you're missing spots, you can always, this will be on YouTube, so you can go back and forth however much you need. Okay, I hope you all have a good one. Don't see any more questions, so you all have a good rest of the day and good rest of the weekend, and best of luck on that upcoming exam.